Alright, welcome back, boys and girls. We're going to go ahead and start putting us a wire in here. So we're going to tie us a UL knot. And I think that was first introduced or first documented in 1944 in the Ashley Book of Knots. But I'm sure it was tied a lot earlier than that. But it's an approved knot by the Underwriters Laboratories. So just remember, we're just going to love tying this knot. One in front of the other. This one's in the front, this one's in the back. This one's going to go in here. This one's going to come out here. And then we're just going to pull it tight. And so there is an underwriter's knot. And of course you pull it and it'll keep from pulling through the hole. And was that hard? Not really. Okay, we've got that power cord soldered in. I've got all the tubes in except the rectifier, and I'm putting that over here. I've got it through my isolation transformer, my rheostat or my variac, and my Ampmeter. I've got the volume, everything on. So basically we're just checking the heater circuits, make sure there's no major shorts or anything. Should see very little current as we go up. Since we're not dealing with high voltage at this point in time, we should not have to stay at I typically like to go 25 volts for a minute or so to 50 volts for a minute or so, 75 in 25, and that's just a random. That's just me. Some people go up to 30, 60. You know, it's in the ballpark. It's in increments of a quarter, we'll say. And basically is you're conditioning your new capacitors when you're applying the high voltage. So right now we're just going to go and just check. I'd have to double check the circuits, but I think the dial lights, at least the red ones, will come on. So we've got it on. So we're going to turn it up. Let's go up to 25 volts or so. See a little current. Which typically a transformer will pull about 100 milliamps. That's just my experience. Now some people may argue and may have different information, but my experience is about 100 milliamps or so. Alright, let's go up a little more. Let's go up to 50. I hope I'm not in the screen here.
Red lights say you.
I'm starting to get some green lights. That's a good indication. Now I can't tell whether or not the filaments are lit in the tubes because they're all metal. And but I've got green lights, and I thought I'd have red ones, but maybe not. So we'll go on up. Still looking about just shy of 200 milliamps, and I'm setting at about 75 volts or so. We won't have any sound in the speaker because we have no high voltage. So let's go on up to about 100 or so. So we are pulling roughly 350 mils. But the filaments of these and the heaters of these tubes. And so I think we're looking okay right now. So let's go on up. Don't see any magic smoke yet. None yet. None of the tubes are excessively hot. Okay. Let me do some double checking of some stuff, and we'll put that rectifier in. All right, got the rectifier in. Let's go up. Let's go up to 25 volts to start with. Let it sit there for a minute or so. Okay, let's go up to about 50 volts or so. Starting to get our glow again. Okay, let's let that set for a few minutes. All right, let's go up to 75. Current's looking good. Less than 300 milliamps. Current's increasing. I just felt the 6L6. Current is increasing. Let's just in case we have to shut down. Starting to get now we've got the red lights on instead of the green. Starting to get a little popping out of the speaker or so. There's our band switch. Let's do a little tuning. I don't think we should be getting any station yet. I don't even have an antenna connected. Let me connect an antenna real quick. Okay, I've connected an antenna. Just don't think I've got enough power or enough voltage. If we're going to start hearing something, we're getting pretty close to the limit of my variac. May have a bad volume control. That's a possibility. Remember, it was froze up. This is our tone. We've got red and green lights. The green are and by the way, I've got an email this morning that this dial is available now through Radio Days. It's on their website now, so I can order it. So that's a good thing. All right. We don't have any magic smoke or anything. Got some sound. Audio amp works. Very loud. But just not receiving anything. So I think we're in pretty good shape right now. So got some troubleshooting to do, obviously. So I've got to go work at the church this morning, so I'm going to leave this till later, and we'll pick this up at another time. Okay, guys, this is on one of the shortwave bands, so we are receiving. Just wasn't on the broadcast band. Let's go up one more, see if that one is working. Could be something in the in that particular band. It could be the bandwidth needs a good cleaning. Very low volume. Excuse me. but it is receiving. And that could be an alignment issue. We'll just have to go through it and see. But it is receiving. The Colorama is not working. Of course, that may not be a strong enough signal to see if the tone works. Maybe a little. Anyway, we do have some receiving, so I had to try it one more time on another band before I went to work at church. So but there's hope. I think we may have some issues to follow through, but we'll figure it out. Alright, as I left you last time, I had gotten some sound out of it. Very low audio, and I knew that I probably had a bad potentiometer here. Didn't have a 2 meg with a switch handy, so I decided to take this apart, and I cleaned it all out. The inside is just a carbon ring around it with a wiper on it, and it's worn, but I was able to clean it out and got it working. The radio has exceeded my Ampmeter, and my Ampmeter goes up to 1 amp, and it's fused at 1 amp also. So this is a 115 watt radio because of all the lamps and the 9 tubes and whatever, you know. So anyway, I cleaned that out, and when I started it back up again, I was wiggling the tubes, and that's one of the things that I think everybody that works on these wiggles tubes, because these things, even though I've cleaned the sockets, sometimes they get bad connections. So I went over to the 6H6 and I wiggled it, and I got louder volume. So I'd turn it off and cleaned it, and I'd push the tube down, and it would get loud, very loud. And so after several tries, I realized that it was not the tube. So I got to looking underneath, and there was a component, a capacitor, that the lead had gotten bent in the handling and everything, and had touched another lead. I should have, I guess, put some spaghetti on it, but I didn't. But I bent it out, and it started working great. Now, the other problem I have with it is the Colorama itself, and I'm trying to do some troubleshooting on it, and that'll be either later in this series or in the next series, and because the radio works fine. I went through the alignment. It works fine, except for the Colorama. The problem is the 6C5 tube that switches the bulbs from the red to the green. When there is no signal, it has a low grid voltage, like -5, and so the tube conducts, and so then the red one's light. Well, as you tune it, that negative voltage goes up to about a -25. Well, when it starts conducting, then the reactor starts the impedance on the secondary, and so the red ones fade and the green ones come up. So initial troubleshooting that I've come up with, the reactor is working, the tube is constantly conducting, and the way I came about that was when I first turned it, well, I've got a -2 on the grid, and I've got to trace that out and find out. That's part of the AVC circuit, so I've got to trace that out and find out why it's a -2 instead of a -5 with a station, or a -25. So I've got to figure out why that voltage is not where it needs to be right now. But I'm going to show you how I determine that the reactor is working and everything. So when I first turn it on, the tube is not conducting, but the lamps will be. So initially, it will show that there's a signal, and so the green ones will be on first with a little bit of red. But as it comes up in power, then the green dims and the red comes up like that. And you can tell a little bit, there is some changing in that 2 to 3 volts, negative volts. You can tell there's you can see the little bit, now I don't know if you can see it on camera or not, but the bulbs do change somewhat. Now I can pull that 6C5, and the green lights will come on and the red ones go down. So that tells me that that reactor is working. The problem is in my bias voltage on that 6C5. And so that's where I've got to go with this and figure that out. I'm pulling 120 watts on this radio right now, so a little over an amp. So it seems to be working okay, except for the Colorama. So that's where I'm at, and I'll keep you posted on the troubleshooting. I'm going to go through every little part, make sure everything is wired correctly, and that why the AVC. That's where I'm at on this. Okay, to prove that this reactor is working and that the 6C5 is working, what I've done is I have taken 2 9-volt batteries and clipped them together like this, made 18 volts. I attached the positive to the ground to create a negative bias. Then I also took a potentiometer, ran it to ground, ran it to the positive side, then the center wiper, I lifted the grid off of the 6C5, and so now I'm going to inject a negative voltage onto the grid of 6C5, and if the negative bias swings back and forth, then we should get some changes here. So I'm going to increase the negative voltage, and we should be getting green lights versus red lights. And then this, so the tube is swinging the way it's supposed to, and so the reactor is swinging the way it's supposed to. So I pretty much narrowed it down that it's got to be in the AVC that's not going negative enough when the signal is tuned in like this. Oh yeah, look what followed me home today. Just as a side note, if you'll recall this output transformer, initially when I checked, it was like 110,000 ohms on the primary. It's supposed to be 161 ohms. Okay. As I would check it or run audio through it, it would get better and better and better. So I said, well, we're going to try it. So running all the voltages and everything through it, and you've heard the radio. It sounds pretty good. So we got it down to like 500 and something ohms. The last, I think, that I reported. But look what's happened after the set is fully operational for a period of time. we're now reading 174 ohms or so. So I've read articles, I've never done it before, where people take and zap these with, take a capacitor or a high voltage DC and zap it, and any bad connection, it kind of basically welds it together. Well, I think that's what's happened here. We've had a bad connection in the transformer connection, where probably these leads go to the transformer, and from all the crud, you've seen the nasty radio and everything. So basically what I think's happened is this has healed itself. Now it's still subject to failure because of that. Should I replace it at this point in time? I'm not going to. I'm just going to wait for the failure and wait for it. The radio's not going to be played that much. It's not going to be a shelf dust bunny or anything up there. Shelf queen, what I guess what you call it, but but we know it's suspect, so hopefully it'll continue to perform for us. So anyway, I thought I'd share that part with you, and but that was kind of a not amazing, but it never happened to me before. So okay. Yes, friends, I have sunk to an all-time low. If you ask anybody about a radio, what the two things that you wish that wouldn't happen, and one would be a transformer and the other is a coil. So I have found a coil that's open. It should read 110 ohms. But zilch nada. So what I've done is I have gotten down here. You can't see my meter because I've got this on a fairly close up, and I'm having trouble to even see it without my magnifying glass. But and the coil reads 110 ohms. And right on that spot, on that particular wire, right, well, there's so much wax. Right there's 113 ohms. So if I am very careful, I can get this wire, splice it back to this, and hopefully repair this. Wish me luck. I'm going in. Okay, perhaps you can see this. I was able to strip back a little bit of the wire right here on top. Now from this point to this point is 113 ohms, which theoretically was supposed to read 110 from here down to here. Okay. So I've checked it from here to here. So the break is, I don't know where. But anyway, from here to here is 113 ohms. The wire for this one comes up and comes out right here. And so I pulled some back, pulled it off here. So what I plan on doing is to go ahead and I've took my ohm meter and checked from here to here, and it is good from here to here. So I'm going to take, and I've raveled off a little bit here, and I'm going to take and cut this, wrap it right there, solder it, and I've got some beeswax or put something in place. Hopefully I can of course, it's kind of protected by this resistor also. So, but the big thing is this small wire. It's the size of a human hair, just about. So, I'm going to try to repair it. We'll see how we do that. I went ahead and cut this wire and I did verify it does go all the way down into here. And then now you can see the size of this thing. And I'm sorry I couldn't show you the process because I'm having to use my magnifier to get down real close on it. And I hope you understand, but I'm trying to explain what I did. Is once I cut this, it's got a silk insulation or wrapping around it. That comes off real easy. I took some lacquer thinner on a Q-tip and I laid it down on the plywood, and I cleaned it all the way around. Instead of pulling and stretching this wire, I used chemicals to strip the varnish off this, so that I did the same thing with this, and I don't have a big window of opportunity to solder to. So my plans is to thread it through there and wrap it 2 or 3 times, make a coil around that right there, and then try to solder it. Okay, I've wrapped it 3 times using an X-Acto knife point and some tweezers, and it was very difficult even with tweezers to get hold of this wire. So I have not soldered it yet, but just wrapped. Under 13 ohms. So now if I can get a solder joint on this, we may have lucked out on this one. There we go. I got it soldered. Now if I can find my beeswax, I'll try to drip some on that and seal that up. But I checked the continuity, and it did read 113 ohms. So hopefully we're good. Alright, touched it up a little bit with some beeswax to hold the loose ends in place, and check the 2.2K, and it's 1.9, which that's kind of, to me, it's kind of unusual for these these resistors. They usually go up in value, but since I'm here, I'm just going to go ahead and replace it. And one less thing I'll have to worry about. Now, if I don't mess the coil up putting this resistor on, I'll be good. But I double checked the value, and it's 114 ohms now. So that hopefully we've got this coil going. We'll see. Time will tell. Went ahead and checked the inductance of that coil, and just for the record, anybody, it's rated 110 ohms, and I read 12.5 millihenries. So probably need to go through here and document the rest of these. But all right, let's put this in. See what happens. I got the coil back in. The AVC voltage is swinging now from -6 to almost -15. I think I need to do another alignment, simply because with a defective coil, there was no way to really, for it to be aligned properly. So I'm going to have to go back through it again. I've noticed that the video makes the Colorama appear fuzzy or whatever, but the thing you need to concentrate on is the dial itself, and this one will be let me see if I can get just the dial, because that's what is important. You don't see the Christmas tree lights or anything like that, so, and it causes it to be a little funky looking. But and I think it'll work better when the with the alignment. So maybe you can see I've tried to dim the bulb so that that's good, knowing that chronic kidney failure. But I think that will be brighter, be better with an alignment and a new dial also. All right, so now we're going to turn towards the cabinet for a few days and see what we can do with that. One of the things I've learned in this is I started going down a certain path looking for a preconceived idea of what was wrong with it, and that was the wrong thing to do instead of keeping an open mind. And I kept looking for in a certain part of the radio instead of going back and looking at the whole radio as a whole. And finally I found that and here was my assumptions. When I brought the radio up, it played rather well. Did an alignment, it played really good. And then what happened was I got to double checking and finally went through, and I found that the RF amplifier, the very first tube in the circuit, did not have any high voltage on it, but it was working fine. Well, I should have checked all the tube voltages. I did not. That was a mistake on my part, and that's something you can learn from. It's something I've learned from. But that first tube, there was enough audio, there was enough radio signal getting through the radio for it to work pretty good. So now it's a real hot receiver. It works really well with that RF amp, and you imagine that, huh? But then when I found that there was no high voltage, then I had to sort out through all the band switch, which is not the easiest thing to read, guys, on a schematic. For me anyway. Some people may be able to pick it right out, but it's very difficult to trace through. And then I finally realized that with some continuity checks, which should have done all the coils, I didn't do all of them simply because of accessibility. But it was in attention to detail and on my part, and making some assumptions, and that's where some of your problems come in. Everybody knows what happens when you assume. So anyway, this has been a challenging radio, but I felt like I needed to put some effort in it because I just want to this is a unique set. So like I say, we're going to start on the cabinet, and we'll have a video. I think probably one video will take care of the cabinet repairs and finishing, and then in the meantime I'll be doing the alignment and everything on this, and then we'll marry them together, and hopefully we will have a nice set to enjoy for years to come. Picked up a lot of subscribers this week, and it really I think I contributed to a plug that Don from Restore Old Radios put on there, recommending my channel, and I appreciate him. He's a great super guy, and he is I really enjoy every time I send him an email, he'll respond back and with something positive or something to really look into and to dig into, and the man is amazing with his skill set that working on these things from the cabinets on through the electronics. It just amazes me and inspires me every time I watch his videos. And I've got one queued up upstairs I've got to go watch today, and really enjoy that. So long-winded enough, I guess, but thanks for all my new subscribers. And if you're not a subscriber, I just click over, or reach over and click. I try to make a quality product and something that we can all learn from. This is not about me. This is about the hobby, and we just a poor slob trying to work on these things and having a great time doing it. So I appreciate all the comments, good or bad. That's how we all learn from here. And because every time I say it, I'll say this again, every time I sit down at this table, I'll learn something. Now, I may forget it next week, but I learned something today, and I will today. So anyway, thanks again. And so from Larry from the hills of Tennessee, thanks for watching.